All right, welcome to the universe. We'll start with the Tyrion Lannister of physics, the Planck length, which is the smallest thing you can sensibly talk about, probably. Next up, we lose our subatomic particle virginity and meet our first neutrino. Don't worry, she's lovely, and she has lots of friends. There are around 65 billion of them, passing through just 1 square centimeter of Earth every second. Up next, we bump into quarks. These come in 7 flavors: up, down, strange, charm, top, bottom, and banana. These are about as close to the building blocks of nature as we've managed to get so far. Next up, we get to the A-list celebrities of the subatomic world, Derek Neutron and Barbara Proton. Usually they engage in a 3-way with Carmen Electron in a kinky arrangement known as atoms. Funny thing about subatomic particles, sometimes they behave as waves, other times as particles depending on how they're feeling and whether or not they're on their period. Which brings us to some more celebrities you will have heard of, such as helium, hydrogen, carbon, and cesium. All of this stuff so far and everything in the universe is controlled by 4 forces. The strong force, which generally binds quarks, protons, and neutrons together. Then there's the weak force, which regulates radioactive decay. The electromagnetic force, which holds atoms and molecules together, basically. And finally, gravity, who is the promiscuous hussy of physics and regulates everything else like universes, but we'll get to that later. All this stuff is contained in a neat little package called the Standard Model, and is about as close to a theory of everything that we've managed to get so far. Generally, little stuff comes under the title quantum physics, and big stuff, which we'll get to in a moment, is known as relativistic physics. Scientists are working very hard on getting the two of them to move in together, but currently they have severe commitment issues. A little further up, when we get to the code of life, deoxyribonucleic acid, also known as DNA, DNA is made of a smease called a tegu, or adenine, thymine, cytosine, and guanine. Depending on how these are arranged, you can get anything from the Ebola virus to papyrus to the German iris to Miley Cyrus. Up some more and we get to cells, some top favorites including red blood, white blood, dendritic, and soft. The next level above that should be familiar. This is where we find raindrops, blue whales, hacky sacks, red tube, the human race, as well as Norway. Out a little further, now we're looking down on all of human history, including all of your insecurities, mortgage repayments, and ex-sexual partners. Which reminds me, Natasha, you're a bitch. Moving on. We get to the 8 planets and 146 moons of our solar system, which doesn't count Pluto, because you're not a planet, Pluto. You're done, mate. It's over. Yeah. Then there's the sun, which is a 4.5 billion-year-old burning ball of hydrogen and helium. Several billion years from now, the sun will rage quit and turn into a red giant goblin. Whatever's left of our planet by then out again, and we find the Milky Way. The Milky Way contains at least 100 billion stars. Stars can be by themselves or orbiting each other, called a binary star system, or occasionally a group of 3, which is called a trinary, ternary, or ménage star. And that's not all. There's also nebulae, which are little starry wombs where lots of stars are born, moons, which either come from planets or random floating matter, and comets, meteors, and a million other types of astronomical bodies that there simply isn't time to talk about. At the center of our galaxy, and lots of other galaxies, are black holes. These are enormous wells of gravity that suck matter in and distort time. Fun fact, if you held your breath while falling into a black hole, you would die, obviously. And then there's the rest of the universe. The Milky Way, our galaxy, is one of at least 100 billion galaxies, each one prettier than the last. Since there are 100 billion galaxies, with at least 100 billion stars in them, that means there are at least 100 billion trillion stars in the universe. The universe itself, as far as we're aware, is about 93 billion light years across. Or, to put it another way, if you were traveling at the speed of light, 300 million meters per second, it would take you 93 billion years to get from one side to the other, except for the fact that the universe is expanding, and the expansion is getting faster, which literally makes no sense. And yeah, that's about it, really. Oh, except there might be parallel universes and hidden dimensions of space, and we completely forgot about time. The universe began, if you can call it that, about 14 billion years ago, and the first few galaxies clammed up a few 100 million years later. A few 100 million years after that, you get the Milky Way, another few, and you've got a very young Earth, then oceans, then life a bit later. Reptiles, dinosaurs, game over for dinosaurs, sorry chaps, evolution of hominids, and finally all of our bullshit here, or here, or here, maybe. It's kind of hard to tell because we're so insignificant, so insignificant. Anyway, nothing means anything, and we're all gonna die. Bye then! Wait. A minute, you forgot to like and subscribe Tate and the universe. See you soon to take out all of you from this simulation world. Till then, bye.